So in this video, I'm now continuing going over solving our radical equations, but a little different in what I'll call like some special cases, so you'll see. But again, just keep in mind, whenever we are raising to that even power, right? If we have a radical square root, this may result in the extraneous solutions, because remember, we cannot equal a negative value here. So that's when we have the extraneous. Also, you could solve by graphing, where you put the left part of the equation and then the right part second. Just keep in mind, whenever it was a value, a number by itself, you had to put y is equal to that number. So again, keep all these little things in mind that we talked about in the previous. But in this video, I'm going to focus on the algebraic. Now, here in our first example, notice how we actually have a radical on both sides of the equation. Now, the radical is by itself here. See how the radical is by itself? Nothing's outside. So technically, we could get rid of the radical. I could just square both sides, right? Because that's the inverse. What we do to one side, we do to the other side. So notice now what happens to both of the radicals. Well, they just cancel out, right? They both do. So now I just bring down 4x, which is equal to 20 minus x. So notice how even though we had two radicals here, they both end up canceling out because we raised both sides to the second power. And now we're just solving our equation for x. Now we do need to gather, so I'm going to add x now here to both sides. And here I've got 5x is equal to 20, divide by 5, and x is equal to 4. So now here, go ahead and try this. You try on your own. And here we go. So again, notice you had a cubed root on both sides of the equation. So that means, what do we do to both sides? Raise to the third power, right? Cubed. So now x plus 2 is equal to, raised to the third power, 6 minus x. So now here, subtracting x, we're going to add x now to both sides. 2x plus 2 is now equal to 6. Now notice you were just solving a two-step. Add or subtract first, so subtract 2 here from both sides. 2x is equal to 4, and then divide by 2, and x is equal to 2. So now in this next example, we do have the radical by itself. So now I'm going to go through and square it, right? We're going to square both sides. We're equal to an x right now. So keep that in mind. We are going to have to check for extraneous solutions because we have a variable. So here we're going to square both sides where the radical cancels out. Now that's x to the second power. Well, what's x to the second power? X squared. X squared is equal to, the radical cancels out. So we're going to bring down 30 minus x. So now notice, what type of equation do we actually have? We have a quadratic, because this is being raised to the second power. We have x squared. But when solving quadratics, quadratics always had to equal what? 0. Right now it's equal to 30 minus x. So we need to move this stuff over. So we're going to add x to both sides. And how are we going to get rid of the 30? Subtract it. So subtract 30 from both sides. So now they both cancel out and we've got 0. So x squared plus x minus 30 is equal to 0. Now notice the x here by itself. So we're going to go through and solve by factoring. So here, what numbers multiply to get us a negative? So that means we need different signs. So it's going to multiply to get a negative and add to get 1. 6 and negative 5, which means x is equal to negative 6 and positive 5. However, we got to check because we're saying this is what x is equal to here and what x is equal to. So remember, our radical cannot equal a negative value. So can our radical equal x, which is negative 6? No. So it cannot equal negative 6 because it cannot equal a negative value. So negative 6 is an extraneous solution. So now let's check. Can our radical equal the other x value, which is 5? Yes, we're good, because then if you notice, you have 30 minus x, 30 minus 5. Well, that's 25. Well, what's the square root of 25? 5. So it works. We're good. So x is only equal to 5 because negative 6 is extraneous. Because again, remember, negative 6 cannot equal a radical. So go ahead and pause the video and try the U-try on your own. And here we go. So here your radical was by itself. So to get rid of it, you need to square both sides. So now the radical cancels out, bring down negative 80 plus 18x is equal to x squared. So again, notice you were solving the quadratic. And so that means quadratics always have to equal what? 0. So you needed to add the 80 to both sides as well as subtract 18x from both sides here. So now canceling out, they equal 0. So x squared minus 18x plus 80 is now equal to 0. Now we can go through and solve by factoring because x squared here has that coefficient of 1 by itself. So here, what numbers multiply to get 80 and add to get negative 18? So both signs are a negative because that's how you're going to multiply to get the positive. And you should have gotten 10 and 8, which means x is equal to positive 10 and positive 8. So can our radical equal positive 10? Yes. Can our radical equal positive 8? Yes. So they were both a solution, no extraneous solutions. So now for example 3. Notice how is our radical by itself? No. We are subtracting 2 from it. So we do need to add 2, right? Get the radical by itself. So we're going to first add 2. So now I've got radical x plus 14 is now equal to x plus 2. So now that our radical is by itself, we are going to go ahead now and square both sides. So now the radical by itself, get rid of it. Now here we've got bring down x plus 14. Now here's where things get tricky. That is x plus 2 to the second power, which is the same as x plus 2 times itself, x plus 2. So in order to solve this, we're going to have to FOIL, or you can set up box method. So x plus 2 times x plus 2. So now here I've got x squared, 2x, 2x, and 2 times 2, which is 4. So here we've got x squared, but then 2x plus 2x is 4x plus 4. So again, notice we are solving a quadratic because here's our x squared, but quadratics always have to equal what? 0. So we've got to move this over. So what are we going to have to do? Well, we're going to have to subtract the x and what else? Subtract the 14, right? Because it's added. Now canceling out to get 0. Now we do have like terms to combine here. So I'm going to bring down x squared, but 4x minus 1x is now 3x. Then 4 minus 14, negative 10. Now notice the x squared here is by itself, that coefficient of 1. So we can solve this equation by factoring. So we're multiplying to get negative 10, so different signs again, and adding to get 3. Positive 5 and negative 2, which means x is equal to negative 5 and positive 2. But let's first check for extraneous. Now notice, here is where the radical was by itself, this line here. So we're going to plug in our x values here for x. So our radical, can it equal? So right now, so again, right, remember we had x plus 2. X is negative 5, so negative 5. Well, what is negative 5 plus 2? Negative 3. So can our radical equal a negative 3? No. So negative 5 is an extraneous solution. So now let's check 2. The radical is equal to 2 plus 2. So can our radical equal 4? Yes, we can have that positive value here. So 2 is our only solution. X is equal to 2. So notice, wherever the radical is by itself, now we have to plug in our solutions here in here for x and solve to see if it's an extraneous. So go ahead and pause the video and try the U-try on your own. And here we go. Now, the radical was by itself, so you had to just go right on into squaring both sides of the equation. So now here I've got 5x minus 9 is equal to, now, remember, this is the same as x minus 1 times itself, x minus 1. So you did need to do box method for this one here, or FOIL. So x minus 1 times itself, x minus 1. So x squared, negative 1x, negative 1x, but negative times a negative is now positive 1 here. So here you have x squared, that's minus 2x plus 1. So again, you were solving a quadratic. Here's your x squared. And quadratics always have to equal what? 0. So you then needed to not only subtract 5x from both sides, but what else? Add 9. So now here's your 0, and x squared minus 7x from negative 2 minus 5 plus 10 from 9 plus 1. Then here you should have noticed x squared is by itself. You have the 1 here. So you could solve this by factoring. So what numbers multiply to get you a positive but add to get you a negative? So 2 negatives to multiply to get you the positive, negative 5 and negative 2. X is equal to 5 and 2, but you also had to check for extraneous. So here, plugging right back in, right? 5 minus 1. 5 minus 1 is 4. So can our radical equal 4? Yes. So we're good on this one. So now let's check 2. 2 minus 1, which is 1. Can our radical equal positive 1? Yes. So they were both a solution, no extraneous. So now go ahead and pause the video and try these two U-tries, or these two problems here that we have on the front. These are more of like the extension if you want to try, especially this second one here. And so for the first one here, we solved these like this was going back like example 2 in the U-try 2. The wording is just asking, what is the solution set? So this is just another way of asking for what is x equal to. So again, keeping in mind if we're going to have any extraneous, right? So here you just square both sides, right? Because the radical was by itself. So now radical canceling out, and I've got 56 minus x is equal to x squared. Now here we're solving a quadratic, but quadratics always have to equal what? 0. So we need to add x to both sides as well as what? Subtract the 56. So this is 0. X squared plus x minus 56. Now notice we are solving by factoring, right? Because the x squared is here by itself with that coefficient of 1. So now numbers that multiply to get negative 56, so different signs, and add to get positive 1. So notice, right, use the answer choices as a guide. Well, what factors are we focusing on for 56? 8 and 7, right? We just have to identify which are going to represent our signs here. So here, to get positive 1, positive 8, and negative 7, which means x is equal to negative 8 and positive 7. But then check for extraneous. Now notice, this is just equal to x. The radical was just equal to x. So can our radical equal negative 8? No. Negative 8 is an extraneous solution. Can our radical equal positive 7? Yes. So that's why the answer is D, because we cannot have, again, remember, right, check for that extraneous. And if it's just x here by itself, then you're just putting the value here in for x. So now the next one, a little different. But again, see, the radical is by itself. So we just have to go through and square both sides of the equation. So now here I'm going to cancel out, and I've got x squared minus 4x minus 5, right? Just bringing down is equal to, now notice, that's 2x minus 10 to the second power, which is the same as 2x minus 10 times itself, 2x minus 10. So you do need to do box method here, or FOIL, right? 2x minus 10 times itself, 2x minus 10. So here you get 4x squared, negative 20x, negative 20x, negative times a negative, positive 100. So now here you end up with 4x squared. Then combining like terms, negative 40x plus 100. But again, we're solving a quadratic, and quadratics have to equal what? 0. Now, you could either A, move everything over here. However, if I subtract 4, I'm going to get a negative here. So I'm going to move everything this direction, because if I subtract x squared from both sides, now I'm going to get a positive 3x squared. We're going to subtract x squared, add 4x, and add 5 here. So now you've got 0, which is equal to 3x squared from 4 minus 1 minus 36x from negative 40 plus 4 plus 95. Sorry, not 95. That's if I were subtracting. 105. So 100 plus 5, 105. Now notice we can't just go right into the factoring just yet, because we do have this coefficient here of 3. So here we go. Do we have a GCF? Can we divide all three numbers? Yes. We can divide all three numbers by 3. So here we've got our GCF of 3. Now taking that out, x squared minus 12x plus 35. Now we can go ahead and start solving here by factoring. So now what numbers multiply to get 35 and add to get negative 12? So again, both negatives, because that's how you're going to multiply to get that positive. Negative 7 and negative 5, which means x is equal to, not 3, right? Because the GCF cancels out, goes away. X is just equal to 7 and 5, but check for extraneous. So plug it back in. Now notice this is 2x minus 10. So 2 times x, 2 times 7 minus 10. 14 minus 10 is 4. So can our radical equal 4? Yes. So now let's check 5. I'll erase. So 2 times 5 minus 10. 10 minus 10. 10, which is 0. Can our radical equal 0? Yes. It can't equal a negative because the square root of 0 is 0. So this can just not be a negative, but it can be a positive and it can equal 0. So both are a solution. That's why the answer is C.